Hello everyone, and welcome to the first challenge question walkthrough for Edexcel's Further Statistics 1, and this is going to be covering Chapter 1. Our first question comes from exercise 1a, and 3 fair 6-sided dice are rolled, and the discrete random variable x is defined as the largest value of these 3 values shown, and we're asked to find the expected value of x. So the expected value of x is defined as the sum of x times the probability that the discrete random variable is equal to x. And so it'd be useful to show the probability distribution in a table with x on top and then the probability that x is equal to x on the bottom. Now if we first consider the probability that x is equal to 1, so this is the probability that 1 is the largest value of the 3 values shown, and that only occurs when all 3 dice roll a 1. And we know that the total number of outcomes possible will be 6 cubed, which is 216 different dice rolls. And so this is only one of those 216. So the probability that x is equal to 1 is equal to 1 out of 216. And now if we consider the probability that x is equal to 2. Now for this to happen, that means each dice must show either a 1 or a 2. And so there are 2 cubed, or 8 different ways to roll the dice, so that none are greater than a 2. And this means the largest value of the 3 values shown will be 2 unless there is no 2 rolled. And this corresponds to the case above, where we only roll 1s. And therefore we have the probability that x is equal to 2 is equal to 8 minus 1, which is 7 over 216. Okay, now for the probability that x is equal to 3. This occurs when there is at least 1 3, and there are no dice that roll more than 3. And we know that there are 3 cubed, or 27 different ways, so that there are no dice that roll more than 3. And now we need to subtract all the different ways where the highest score isn't 3, and those will be when the highest score is 1 or 2. And so we've got 27 minus 7 minus 1, or 19. So we have 19 different rolls that give us x is equal to 3. So the probability that x is equal to 3 is 19 over 216. And we can apply the same logic to the probability that x is equal to 4. We have that is equal to 4 cubed, and then taking away the 19, the 7 and the 1 over 216, which gives us 37 over 216. Doing the same for the probability that x is equal to 5. 5 cubed minus 37 minus 19 minus 7 minus 1 over 216, which gives us 61 over 216. And doing the same for the probability x is equal to 6 gives us 6 cubed minus 61 minus 37 minus 19 minus 7 minus 1 all over 216, and that is equal to 91 out of 216. And we can notice that this is the same calculation as one take away the sum of these values here, which would also give us the final value here, as we know all the probabilities have to sum to 1. Okay. And now, using the formula we have up here, we have that the expected value of x is equal to 1 times 1 over 216 plus 2 times 7 over 216 plus 3 times 19 over 216 plus 4 times 37 over 216 plus 5 times 61 over 216 plus 6 times 91 over 216 gives us 1071 over 216, which is equal to 4.9583 to 4 decimal places. And that is our final answer. Okay, and our next question is from exercise 1c. Show that the expected value of x minus e of x all squared is equal to e of x squared minus e of x all squared. So if we expand the brackets here first, we'll have x squared minus 2x e of x, and then plus e of x all squared. And as we're simplifying this, we can remember two golden rules. The first one is that e of x is just a constant. And the second one is that the expected value of a sum of two functions can be split, so we have the expected value of f of x plus the expected value of g of x. And using these rules, we have this is equal to, splitting each of these three terms separately, the expected value of x squared plus the expected value of minus 2x e of x plus the expected value of e of x squared. And now we can leave the e of x squared just as it is, and from this term we can take out the constant minus 2 e of x, which leaves us with e of x. And here we've got the expected value of e of x squared, and because e of x is just a constant, that means e of x squared is also just a constant, and the expected value of a constant is just the constant, so we're left with just e of x squared. And this middle term we can just write as minus 2 e of x squared plus e of x squared, and that leaves us with just minus 1 e of x squared as required. And our final question is from mixed exercise 1. Let n be a positive integer and suppose that x is a discrete random variable with the probability that x is equal to I is equal to 1 over n for I equals 1 up until n. And we're asked to show that the expected value of x is equal to n plus 1 over 2 and the variance of x is equal to n plus 1 times n minus 1 over 12. So first of all, we can spot that this is a discrete uniform distribution. As for all of the values of I, the probability is equal to 1 over n. So if we look at a table with this probability distribution, with I on top and the probability that x is equal to I on the bottom. So for 1, the probability is 1 over n. For 2, the probability is also 1 over n, and so on, so on, so on, until we reach n, when the probability is still 1 over n. And so we can see that the expected value of x, which is equal to the sum of I times the probability x is equal to I, is equal to 1 times 1 over n plus 2 times 1 over n plus and so on and so on and so on until we reach n times 1 over n. And if we factorise 1 over n out of this, we're left with just 1 plus 2 plus 3 and so on and so on and so on up until n. And using these sums of series formulae from core pure 1, we get this is equal to 1 over n times n plus 1 over 2. And so the n's cancel and we're left with n plus 1 over 2 as required. Now to find the variance of x, this is equal to the expected value of x squared minus the expected value of x all squared. And we know e of x, but we don't know e of x squared. And we know that the expected value of x squared is equal to the sum of I squared times the probability that x is equal to I. So this is just equal to 1 squared times 1 over n plus 2 squared times 1 over n plus so on, so on, so on, until we get to n squared times 1 over n. Factorising the 1 over n out again, we get 1 squared plus 2 squared plus 3 squared and so on until we reach n squared. And again, using the sums of series formula from CP1, we get this is equal to 1 over n times a sixth n plus 1, 2n plus 1. And the n's will cancel again. And so we're left with 1/6 n plus 1 times 2n plus 1. And so we have this is equal to 1/6 n plus 1, 2n plus 1, and minus a half n plus 1, all squared. And this is equal to 1/6 n plus 1, 2n plus 1, minus a quarter n plus 1 squared. And if we factor out 1/12 n plus 1, on the inside we're left with 2 times 2n plus 1 minus 3 lots of n plus 1, which is equal to 1/12 n plus 1. Here we've got 4n minus 3n, so that's just n, and 2 minus 3, which is minus 1, as required. And that is the end of the challenge question walkthrough for Edexcel's Further Statistics 1, Chapter 1.